Hi everyone, let's get started. So the agenda today is that we will see some of the introduction to R because many of you haven't used R before. So we thought we'll take this as a chance to introduce and whatever important functions that we'll be using towards this course, some packages like dplayer and all we will introduce today, so that the prerequisites everyone can be on the same page. And I also hope you got a chance to look at the links that I've sent, the videos and all. And but I'm just assume that you're again new to R, so I'll start from scratch and let's do some data wrangling operation. We'll take up some data sets and let's try to build some stories around it. So as I mentioned during the introduction call, we'll be primarily using RStudio, and moment you use RStudio, you will might be seeing a lot of panels, individual panels like this. So there is a console panel here, and you can open a new file which will bring up a RScript panel where you can write bunch of codes. And on the right hand side, on the top right, you will see whatever variables I have used before this would get ideally saved, so that I need not recreate them every time. Or if you want to start everything from scratch, you can clear objects from the workspace using this brush icon, which will just remove every variables that was stored earlier. So right now it's like a fresh RStudio that you have kept open. And in the bottom right, you will see a lot of different options, like in the current working directory, you have these many files, and if you plot anything, it will come in this page, and you can use this to install any of the packages, like if you want to install dplayer or TM package or word cloud package, we'll be using ggplot2 a lot. So all these packages, you can just search for it and install it. And if you are looking for any help, those help items will come here. For example, if I can just say help plots, if I enter, so it is already help on topic. Let's pull out something else. For example, let's load a library dplayer. So now we have loaded a library into our environment, and let's say you want to know about a group by object, group by function. Help regarding group bys will come in this section, and you can see a package name ::: group by. You can click on this, and description about this particular function will be available in this window. Likewise, there are multiple other functionalities you have. You can use file to open up a recent files, or you can open some other file in your system, and you can change the look and feel using tools and global options, the background theme, font size, all those you can change in the appearance tab. So this is typically to customize your complete RStudio. And in the console, I said we can start writing small code snippets. For example, there are different numeric types that are support. For example, x is equal to 1. If I say, a new variable is created on the top right, which has x, which is numeric, and takes 48 bytes, and the value is 1. Likewise, I can create a vector. For example, I create a vector called ages. Vectors are nothing but collection of elements. So you can have numbers together, strings together, or at times you can have a mix of these. So it need not be homogeneous, it could be heterogeneous elements as well. So here, whenever you want to create vector, we'll be using a keyword called C. So C of, and whatever elements you want to group them for, put them together. For example, I want to create elements like 50, 100, 200, some other value. Ideally, age cannot be more than 200 and all. So let's say 10, 75, 56, like this. So, and another variable is created here, which says age is numeric again. So the values inside that is a numeric, but this variable is of type vector, which is collection of elements. So you can see there are 4 elements in it, and these it will just give you preview of elements here. So whatever variables you create, those variables names will appear and some details about that variable will get created here. And good part is we need not define what type of variable we are going to create. R will automatically able to detect them if it is of type string. For example, let's say I created another vector C 50 sorry Chennai and Bangalore. So new variable is created. Now it says if it is of type character. So earlier it is of type numeric. So the variable is a vector, but the elements inside the variable depends upon what values it has. So here in the case of ages, it is numbers, whereas in the case of city, it is character. So it will automatically detect what kind of elements you have inside the vector, and based upon that, it will decide what should be the type of the vector. Whereas here x is just integer. So likewise we have a few other data elements. So we have list, we have data frames, we have tables, we have matrix. So there are a lot of data types that are available. Most of the time we will be using vector, we'll be using list, we'll be using data frames, because very rarely we will create our own data. Instead we will read data from files and start using it, and most of the time we are working with structured data, so it will be either from a database or it will be from a CSV file or Excel file, which is going to be a structured data. So most of the time we are going to work with structured data, and it is going to be in the form of data frames. But there are few sections in our course where we'll be using unstructured data as well. For example, we'll be picking up some text data and doing some frequency analysis, what kind of words used a lot, and what is the theme of the text. And also we'll be pulling out some Twitter data and then doing some analysis on top of that. But even that, it will be in one of the column of a data frame. So typically it's going to be a structured or a semi-structured data is what we are going to deal in the course. So you get comfortable with vector, you get comfortable with list and data frames. So let's look at these few of one by one. The problem with console, typing something in console is whatever you type, if you want to recreate or if you want to run 2-3 lines together, you have to run one by one. So let's say you write 10 or 15 lines of code, but you made some mistake in the 5th line, you will not have option to run them all together. Instead, what you can do is put them in a script file. So that is where our script will help you. And how do you create a script file? Go to File, New File, R script, or you can also use Ctrl+Shift+N. So when you create a script file, you get a tab like this on top, where initially it will have a name untitled. You can save this first of all. So save this in a local drive so that whatever change that you do, it will get saved automatically, or you can keep using Ctrl+S to save it every now and then. Let's say I store it in desktop, or let's create a new folder. In this folder, I'm going to say introduction, and the extension that you have to use is .R for R script. So now whatever I write here, for example, x is equal to 1, in the next line, same thing I can use, ages is equal to, and city is equal to. So all this I can run them one by one. So here you can either use run button. On this top menu, you have a top panel, you have the run button, or you can also be on any of the lines and just press Ctrl Enter. It will automatically execute that particular line. You could be anywhere inside that particular line. You need not select it. You can just click and be there in any of the character in that particular line, and it will automatically execute. You just have to press Ctrl Enter. It will execute that particular line and come to the next line. So if you want to run all that together, do a control A and control enter, it will run all this code one by one, and it will automatically get meaning you can save it as well. You press control S, you save it then and there, so that you don't lose anything. So that is the advantage of R script. And also, if you want to pass on the code to someone, you can pass it on. Later in the course, as part of the first week, you will be having a video called R Markdown. So we will not be using much of R script. Instead, we'll be using something called R Markdown. So file, new file, and we'll be clicking on R Markdown. I have a introduction video on R Markdown, so I'm skipping that part right now. So when you get the videos, you will have an option to see what is in R Markdown and how different it is from the R script. Otherwise, the code, everything will be remaining same, just that the interface in which we are going to execute these codes will be slightly different, and it will be a better way of executing the code than the regular R script. And you want to create any comment, you can just use hash and say this is a comment. So these are some basic data types and how you get familiar with RStudio. Let's understand how do we use for loop in R. So let's say I want to print the cities one by one, and let's say we have few more cities. So if you feel that it gets extended to the right hand side too much, you can just write continue in the next line, but make sure that you have comma and then you continue, otherwise it might break. And if you want to have, if you are having a very small window, you can continue it in the next line and it automatically takes the indentation and all. So let's say I have these cities. How do I loop into each of the city? So I can use a for loop, and there are two ways. One, you say I will go through I will create some index, and then you can go through each of the city, or you can say for x in, or for city in, I rename this to cities, for city in cities. So this is the syntax. For is a keyword, you have to use a parenthesis, and inside this is going to be a temporary variable where every time city will be assigned to city here, and cities is a vector which has bunch of city names inside it. So this for loop will run 4 times because we have 4 cities in it, and inside this we can print city. And how do you execute? Just be the first line, just press Control Enter. It will automatically execute all the lines, and one by one you will have the results as well. So this is how you loop through each of the element in a vector. For example, very quickly we can loop in through the ages vector that we have. So for age in ages, print age. So it will automatically print one by one. So this is one approach where you directly access the element, or another approach is you say I will create a sequence first, like 1, 2, 3, 4, or like 5, 6 till how many ever elements I have in my vector. Let's say I say sequence 1, comma, and we have, let's take 4 elements in ages. So I can say sequence 1, comma 4 and print I. When you do this, you get only the sequence. So these are basically placeholder or the position of individual elements which we are first creating. So we create the positions, and then you can say ages of I, which will pull out the corresponding ages one at a time. So first time the value of I will be 1, second time it will be 2, 3 and 4, and then it will stop because sequence will create a vector from 1 to 4. So for I in a vector which is a sequence of 1 to 4, and inside this we can say ages of I, and you can also say print cities of I. So at a time you are accessing one element in ages and another element in cities. When you execute it, so you can see first age get printed followed by city, second age, second city. Likewise, you can use position, in which case you will be using sequence here, or you can directly access the element, in which case you will not have any position details with you. Instead, you will directly have the element value. So there are two types of for loops that you can generally use. If you do not know how many elements you will have in a vector, what you can do is, so let's say I do not know how many elements are there in ages or city. I can say length of ages, and I'm hoping that both ages and cities will have similar number of elements. So if you do not know how many elements you might have, because typically when we are doing data wrangling, the vector might come from some other operation, and you will not know upfront in a data how many cities are there, how many countries are there. So here, now instead of hard coding how many elements are there, we can directly specify the length here as well. So this is a proper way of looping through each of the element using index concept or the position concept. Let's understand what is a list. So we learned so far what is a vector. So this is vector, which is collection of elements, and we learned how to use for loop. Now we are going to use learn what is called as a list. List is almost similar to a vector. It is also going to have collection of elements with you. Just for every element, we can label them. So we can say the first element should have a label called X, second element should have label Y. So let's see how we create them. We can say students list of, you can say Kadir equal to 100 and money equal to 20 and Suguma equal to 60. So I have a bunch of elements numbers with me, and for each of the numbers I can have a name to it. So instead of accessing elements by their position, I can access the elements by their names. For example, I can say students dollar, which will list you all the names that are available in the list, and I can say students dollar money, control enter, it will print 20. Otherwise, in ages, if you want to access some element, you have to say ages of 1 or ages of 2. So this is accessing elements by their position, accessing elements by their names. So list is useful for that, and within list you can have vectors, and you can have data frames as well within list. So it can go complex. So it need not be collection of individual elements. It could be collection of vectors itself. So that I'm just not going too deep inside that. So let's understand what is a data frame, because that is the crux of our course. Though vector list we'll be using in between our operations, which is very much needed, data frames are something that we will keep on using it throughout the course. So let's understand them in detail. Data frame. Data frame is like a table where you will have rows and columns. Rows will have position, columns will have their name, just like how we view them in a Excel file. So let's read a data set very quickly. So let's read a ODI data set. ODI read.csv is a function which is part of base R itself. So read.csv, in parenthesis we have to give location of the data set. So e data set ODI batting. By default it assumes comma separated. If you have any other delimiter, you can specify them. Also you have a separator parameter with you. So if you are not sure what is the variable name that you have to use for separator or something, you can quickly use question mark the function name, which is read.csv. So very quickly you will have the help file here. So you can see read_csv. You also have bunch of elements. You want to check the column names, you want to skip any of the rows, and in that you can specify the delimiter using SCP. I'm not sure where it is available here, but if you have some other delimiter, you can use SCP argument, and different arguments are available here as well. So very quickly, if you are not sure about the parameter names, you can go and look at the documentation of it. Otherwise, you can just look at Stack Overflow. Most of the common operations you can get cleared of your doubts in Stack Overflow. So now I have read a data frame. If I want to know what is the type of the variable that I'm using, I can use a variable called class, function called class of ODI. Okay, I haven't run it. So control enter will run this first, and class of ODI says it is a data.frame, whereas class of ages will tell it is of type numeric because it is a vector with collection of numerical elements, whereas class of cities is a vector with collection of characters in it, so it will come as character, whereas class of students will be a list. So these are different data types that we have. Let's get back to our ODI data set. So moment you get a data set, ideally you would like to view them. First of all, understand what are the different columns in it, what are the different rows, how are structured. That is what we typically do. By looking at the data itself, will give a lot of information, get a feel about the data set. So you can use view where capital V is used. So it's case sensitive. So use capital V, view ODI. When you do this, it will open up another tab in the same window, and you can see the preview of first few rows in your data set. So we have a column called country, we have a column called player, runs that they have scored, and what is the strike rate, in which date it was played, in which ground, against whom they played. So a lot of columns, numerical columns, categorical columns, date columns are available, and we'll be using this data set a lot in our course also. So view will quickly help you to preview your data set. If you want to print locally for first few rows, you can use head of ODI. So here in console, you will see those print statements. So here we have looked at the first few rows in ODI data set. You can also look at a few more parameters. For example, dim of ODI will give you how many rows and how many columns are there. Structure of ODI will give you a complete summary of your data frame. So let's look at that in detail. So str of ODI will give you the structure of your ODI, individual columns, how it is structured. Let's understand this one by one. So it says structure of ODI. It's a data frame with 55,926 rows and 8 variables, which is like 8 columns. And we have a country column, which is of type factor. So usually if you have categorical column, country, state, or you have, let's say, names and all, we can use, we'll be having a variable type called factor. And next we have a player column that is also of type factor. And next to that, you will also have how many unique values you have. So it says there are 22 unique values in the column called country. So there are 22 unique countries in which we have the data, and there are 1,936 unique players in our column, and runs is a integer column, score rate is a numerical column. So score rate contains decimal number, so it is a numeric, whereas runs contain just integer, so it is int. Likewise, match date is a factor, ground is a factor, versus is a factor, and URL is also factor. So it will also give you few previews, like values like Afghanistan is there in country, values like Amir Hanif is there, and first a few samples in that particular column. It will try to give a preview so that you get a feel about the data set, what kind of values are available in those. So structure command is always a useful one. Whenever you read a data set, first look at the structure, understand the column type. So every column type you should know, because certain operation will not work on character type. You have to convert them into a factor column. So whenever you want to convert between data types. Let's say you want to convert, or we'll look at that in some time. Before that, we'll learn few more basics. You can access the individual columns. Yeah, so factor is nothing but a categorical column. Like if you have a strings, you have a column like state or country, or you have a column like names, which will be keep on repeating. For example, here runs is a numerical column, whereas country Afghanistan keep repeating a lot, and you will also see India repeating, Australia repeating. So basically these are your qualitative columns, and numerical columns are quantitative columns. Categorical columns we call it, or qualitative columns, or in R at least they are called as factor columns. Just that the string columns, but which are repeating continuously. So basically your qualitative columns is called as factor columns. Now let's see how we identify the individual columns, or how do we access the individual columns here. First of all, if you want to get to know all the column names, you can use call names, and you can say ODI, which will give you the list of column names in your data frame. And if you want to quickly identify how many such column names are there, you can use length function on top of this, and it will be 8 columns, which is also same that we get from the dim function. Dimension will give you number of rows, which is 55,926, and number of columns, which is 8. So now, as I said before, if you want to access any particular column, we can say ODI $, and there are multiple options available to access a column. Once it's simple operation is use a $ symbol. So this, if you remember, even in list we said students $, and it will list out all the names that are available. And even in data frame, you can use $, and it will list down all the column names alone. And you can say ODI $ country. Maybe if you want to just look at the first 5 rows, because there are 55,000 rows that are available. If you just print ODI $ country, it will keep on printing. Instead, you can just use head of ODI country. So it says Afghanistan, Afghanistan, Afghanistan. So first 5 rows, first 6 rows at least contains only the country Afghanistan. So you can see the index. So first index, first position is Afghanistan, and in the second line you have the 6th position element. So that's why you see the 6 value here. So how, depending upon how many elements it prints in the line, it depends, the number depends upon the printing, the way it prints. So sometimes you see 130, sometimes you 330. For example, if you want to print more than 6 elements, you can say I want to print first 50 elements. So you just do Control Enter. So it's all Afghanistan, and you can see, so this is 5th element, this is 25th element. So it's just a number that you see, that is the position of that particular element. So this is one way, or you can also say ODI, use square brackets and say comma country, which means that you want all the rows, so you are not giving any number here, but you want the column country. So it will give you all the rows and country. Or if you are looking for first few rows, or like say first 5 rows or something, you can use 1:5 and then country, which will print the first 5 rows, the country names alone. So this is one of the way. So before comma, it is the information about your rows. After comma, it is information about your columns. So you can also give multiple columns here. You can say I want country, and I also want the player name, in which case you will get this. You will have country, you will have player name as well. So this is how you access a particular element in a list or in a data frame. So you can also say I want the 500th row, and I want to know the country and player, in which case it will give you only 1 row. So country is Australia, and it is Ricky Ponting. So you can filter rows, you can filter columns. Either if you want to filter columns directly, you can use $country, and if you want to filter both rows and columns together, you can use square bracket. So that is called a subscript. So first, before comma, it is for rows, and after comma, it is for the column. So if you want all the columns but a specific row, let's say on the 10th row alone, you want all the column, leave the second part blank, which will give you 10th row all the columns. So this is 10th row all the columns. Whereas if you say comma and then country, it will print all the countries in all the rows. So it will keep on printing. And here it is country column all rows. So all rows in country column. So depending upon what you want, either you give information about both rows and column, or if you want a specific row but all the columns, ignore the second part. If you want all the rows but a specific column, ignore the first part. So this is how you filter a data frame. So what we have learned, I quickly summarize and then I will take some doubts if you have. So what we learned, different data types. We saw this is an integer, and this is a vector, which is collection of elements. It can have homogeneous and heterogeneous elements. We learned how to loop them through each of them one by one, either directly using their value or using position and then accessing the corresponding element. We learned something called list. Difference between list and a vector is list can have names for each of the element, and list can be complex as well. And data frames, generally we read CSV files. It will be in the form of tabular structure where you have rows and columns. You use head command to print first 6 rows. You use dim command to get the number of rows and columns. And structure command give you column wise data type and preview. So whether it is factor or integer, character and all. Column names to give you the individual column names, and you can print first 50 rows also, and this is filtering both rows and column. So filter specific row and columns. So here we are specifying a row but not a column, so all columns will come. Here we are specifying the column detail but not row, so all the rows but one column will come. So this is how we filter different types of filtering in data frames. Before I move on to the library deep layer, where we will understand how to do grouping, summarization, filtering and all, is there any questions that I can take? Either you can talk or you can type it in the chat window. I will take one at a time. What is significance of table? That is mostly used with IDR package. Maybe I think early stage it might be a bit difficult for you to understand. So I will skip that question as of now. Maybe next time when we discuss, I will take it up, because mostly we will not be using table in this course at least. And okay, if you're not able to broadcast to all attendees, that's fine. I will read the question and explain it. And the next question is, how can we create a unique list? Fine, I will show you. I guess you're asking like unique countries and unique player names. And vectors are heterogeneous. Yes, you can have a mix of elements as well. It shouldn't be a problem. And there is a link that you have given, which is summary. I'm not sure what is the link that you have given. I will check it out, Srinivas, and then maybe later on add it. 22 levels, no issues. So 22 levels, what does it mean? So it means that there are 22 unique countries in that particular column. For example, when you say print ODI, print unique ODI $country, it will print all the unique values in that column called country, and which is nothing but 22. So totally 22 unique countries we have. So That is the number of levels in that particular column. For example, when you do this for the column player, we saw there were around 1926 levels, that is 1936 unique players. So levels are nothing but the unique number of elements that you have in a factor column. And when the index starts from 0, what does 0 store? 0 will just get NA, I guess. It starts from 1, whereas in Python it starts from 0, where in R at least it starts with 1. 0, I guess you will get NA. And how many max columns rows are supported, it depends upon the RAM that you are using. Usually columns might not go beyond 50, 70, even in most of the data sets not beyond 100, and very easily it can handle. Number of rows depends upon what is your RAM that you are using. I have tried reading 2 GB of data set, was okay in my machine. Completely depends on the machine that you have, because all the data is going to sit on the RAM. So depends upon the RAM that you are using. And for mix of elements, what could be the data type? Data type could be character, because if you have numbers and strings together, ideally it should be a character type. And if you type length, will it take automatically from array any limitation? I couldn't get that question properly, Srinivas. If you type length, will it automatically, will it take automatically? Yeah, type will be automatically taken. You can override the type. You can do a typecasting, and you can convert factor to string, factor to character. For example, if you have, if you want to convert player into character, you do not want to store it as factor, so you can say ODI dollar player is equal to as dot character, and then you can say ODI and player. So this will make sure that player column is not a factor, it is of type character. So if you say class or you just say structure of ODI, you will see the player column is of type character. Earlier it was of type player, so it will not have level details and all. Character is like a string column, whereas factor is like a qualitative column. So you can do typecasting. You can convert string to number if you have everything a number with which are overlaid on the codes and all. And I'll take few more and then I'll continue. Maybe towards the end, if you have, we will take it up. Can we have floating numbers as well? Yes, you can have floating numbers. If you type length, okay, that I have addressed. The use of length is little confusing. Length in R, number of columns. No, length of in R is not number of column, it is number of elements. For example, when you say length of ODI, it just gives 8 because this is a data frame. So it will give you 8 columns, but never use length on a data frame. Instead, you should use it on a vector or a list. For example, you can say ODI $country, in which case it will give 55,926. When you are dealing with data frame, ideally you should use dim function and directly give ODI. Otherwise, it will just give number of columns alone. It acts internally like a list, and it contains 8 elements, and then every element in the list contains 5,926. So whenever you are using data frame, use dim function. Whenever you want to look at number of elements, ideally pinpoint to that particular column and then get it or point it to a vector. But length will always give you, supposed to give you the number of elements in a vector. And fine, I have denormalized data in tables where number of columns greater than 450 and just 1 day's worth of data is more than 1 GB. I wanted to know if I would able to process 1 month of data in one go. If it is a very big data that your RAM doesn't support, you cannot read all those in your machine. Instead, you have to rely upon a database, and maybe you query them, do the summarization in the database itself in the form of stored procedures or views, and get the aggregated results alone in R, and then play around with your visual. Because R is not good if your data size is very high, and because typical 8 GB RAM your system will already take 4 or 5 in it, and you will have 4 GB only free. In that 2 GB or 3 GB, if you dedicate it to RAM, ideally system will crash. So I would suggest, if you have very large data set, you put them in database and think. How do we query from database? Maybe next time I'll take it. I haven't keep it for today agenda. I will show you how we can query it from MySQL database. And difference between vector and list, only that we can name elements. Yeah, I think at a high level, if you keep that as a difference, that's okay as of now. The list, most of the time, it's also used to store complex elements as well. But you are right, it is more do with the naming. So I'll take the rest of the other questions. Maybe if you have time towards the end, I will take it. So let's move on to the library dplyr. So whenever you are using external packages, first you have to make sure that they are included in library using library function. And you can say dplyr : if you want to know what are the kind of functions that are available in the dplyr package or in any other package. So : will help you to browse through all the functions that are available, and it's a very exhaustive list of functions that we have. So ideally we will use group by, summarize, and filter, select functions. Let's look at them very quickly. And we'll be using pipeline symbol, something that I mentioned initially. This is very specific. This symbol is very specific for dplyr. If you don't if you didn't load dplyr, if you didn't load dplyr, the pipeline symbol will not work, and it will throw out an error saying that it is not able to recognize this symbol. So this is very specific to dplyr. So let's do some operation on the data sets that we have, and then we'll understand each of the functions. So let's say first I want to filter for a player. How do I do it? I have a data frame named ODI. I can pass on this data frame to another function, which is filter. Filter player is the column name. So whenever you are working with dplyr, the column names need not be put in a string. For example, whereas here when we are using, the column names were wrapped with single quotes, whereas here I'm directly writing it. So that is one of the difference that you keep in mind. While working with dplyr, column names need not be enclosed with single or double quotes. So player, I want to filter for one player. Let's say I want to filter only for Sachin. Player equal to, because this is a logical comparison. You cannot use single equal to, because single equal to is for assignment, double equal to is for logical checking, comparison between your left hand side and your right hand side. Sachin R. Tendulkar. I know the name, so I'm typing it. If you do not know the exact string, better you have to look at the data and then get it, or you have to use regular expressions to say that words that starts with Sachin also. But to keep it simple, you need to know the player name or the string that you are going to search. So what happens? ODI data is passed to the function filter using pipeline character. So this is one easy way of writing it. Otherwise you have to do ODI square bracket and player equal to say Sachin. So it will be a little bit complex to understand, but this is very easy. So whatever results you get in one operation, you can pass it on to the other operation, and then you can further pass it on to another function, which is, let's say, end row. So end row will give you number of rows that has been filtered in the previous function. So this will tell you that there are 442 rows which has player equal to Sachin R. Tendulkar. So this is how you filter for a single element in a single column. So you can also specify multi filters. For example, you can say player equal to Sachin R. Tendulkar, and you can use AND operator and say versus is equal to Australia. So if you feel it's going to the next line, you can wrap it in the next, meaning if it goes towards the right hand side, you can wrap it in the next line, but make sure that it is continued using the pipeline. The pipeline cannot come in the line next line, so R will not able to understand that is the continuation line. So make sure that you have pipeline in the first line and then followed by whatever operation you want to do in the second line. So versus equal to Australia, and then you can say end row. So now it says 67. So where player is Sachin as well as against Australia. So this is how you do in a single column. Using multiple columns, you filter, or in a single column itself. Let's say you want to filter for 2 players. So player, if I want to select for 2 players, you cannot use equal to. Instead, you can say percentage in percentage. So player in a vector that you can pass with list of name. Maybe you can say Sachin R. Tendulkar, and you can also say, let's say Ashish Nehra. These names I know, so I am writing it. Otherwise, you have to look at the data and get the exact name, because it's case sensitive, and even if one word or one character is missing, it will not give the correct result. So it says totally 488 rows are available, in which it's either Sachin or Nehra. So you can also look at the data. For example, you can does it support wildcard matching? Yeah, you have to use a few regular expression concepts. I'm skipping that as of now, but yes, you can do it. So you can say view, or you can store it in a variable saying that player underscore subset is equal to this, and you can view this data frame now. So I've removed end row, and because if you make end row, that will become one value. Instead, I want to look at the data alone, so you can use view. So you can see a subset of data, which is just a player, and you will have Ashish Nehra as well. So this is how you do multiple type of filtering. The first type of filtering is in a single column, single value, multiple columns, single value, and single column, multiple values. So different types of filters exist. Let's look at group by operation. So this is filtering. Let's look at group by operation. Let's say I want to identify player wise total number of runs. So how do I do it? First, I have to pass the ODI data set to the group by function, and on what column name should I group by? I should group by the column name on player. If you want to group by 2 columns, you can just pass on them by separating with comma. So ODI group by country comma player also you can do it. So depending upon how many columns you want for group by. So whatever results you get, you pass it on to the next function, which is summarize. Summarize, and our objective is to condense this data into a short thing, and I want to summarize total runs for every player. So I can say sum of runs, in which case it will print the first few. There are 1926 rows, so it will print first few rows after summarizing. So let's understand this carefully. So it has created a table here, and imagine it's almost like a data frame, and we create a player, and the first column is player, the second column is a weird name it comes, whatever operation that we have used, it has come as that. So let's see how we rename the column, and the first column is of type character, second column is of type int, and we have the individual values for every player. We have the individual values, and by default it is sorted by the player name, and you see there are few NA values also coming. So what happens, there could be 2 possibilities. One, this particular player runs would have been completely empty, or even if there is only one NA value for that player, all the other values also will not be used, because when you try to do sum along with the numbers with NA, the output also will be NA. So ideally what we should be doing is, while taking sum, we should try to ignore NA. So that is done using NA.rm equal to true. So ODI group by player, summarize some of the runs column, and while summing up, ignore NAs. It will not remove it from the data frame. It will just ignore while taking the sum. And if you want to rename the column, you can say total underscore runs is equal to sum of runs. So now if you do it, now you don't see any NA values here, because while calculating sum alone it will ignore. So that is the main difference that you have to remember. And you can continue create more columns also. You can say average runs is equal to mean of runs, and you can say NA.rm equal to true, which will ignore NA while calculating average. So you have two columns now. First column is total runs and second column is average runs. So at this stage, you will not have access to any other column other than these three columns. So ODI data might have, let's say, versus column, but if you want to do any other operation continuing from here, you cannot use versus column, you cannot use country column, because you have summarized and you have a very short data frame, small data frame now, and you can access only these columns. So within these columns, you can do whatever operations you want. For example, I want to sort it by total runs, and I do not want to sort it by, let's say, the player name. So I can say I'm continuing in the next line. So the pipeline should be in the previous line, and arrange total runs. And we can say continuing, and we can print first 5 rows alone. And Ritu, I will come to your question in some time. And let's say ODI group by player, summarized it, computed 2 columns, and arranging the data frame by total runs, and then picking the first 6 rows alone. So if you look at it, the first few rows are 0 values, because we have done a ascending sorting. By default, it will do ascending sorting. If you want to do descending sorting, you can use DESC and then wrap it with total runs, or a better shortcut is just introduce a negate symbol with a minus symbol, which will do a descending sorting. So it will not do any mathematical operation. Inside arrange, if you use minus, it will just reverse the sorting and it will be descending sorting. So in which case now you have values sorted in a descending order. So Sachin total runs is 18,111, and he is the topmost player in terms of total runs. So you can also keep adding more rows. You can say total underscore matches is equal to number of rows each player is appearing in the data set. So that is given by n of. N row will give you data frame overall number of rows, whereas n of will give you within the group by object for every player how many rows are there. So it's almost like count of rows. If you do it in pivot, instead of sum, we might be changing the values to count, right? That is exactly same with n of. We will not be using n row here. Instead, inside summarize function, we'll be using n of. So now we have total matches as well. So you can decide upon which column to sort it. Based on that, it will sort the results and it will give it to you. So this is how we can get a player performance and different metrics we can use inside the summarize function. So this summarizes group by. Select is simple. We just have to use select function if you want to show only few columns to the end user. So we can say select, and we can say I want a player column and total matches alone. I do not want to show the runs column. In which case you say select, give the individual column names here. So you will get only the player column and the total matches column. So this is what player does. So you can keep doing multiple operations in a single line, and it is very readable. For example, you say ODI is grouped by player and it is summarized with these summary operations, and then the result is passed to arrange function. Once we have arranged, we are picking the first 6 rows, and then we are selecting the first 2 columns. So this is the beauty of the pipeline symbol. Otherwise, we'll be using a lot of subscripts within a within square brackets. We'll write something, and then we have to store it in multiple variables and to get the final output. Instead, the pipeline operator will be very handy, and it will be very readable as well. And if you want, the results can be stored in a variable summary. So that is one option. Inside this, you can also use filter command. For example, you can say country equal to India, and then you do a group by player to understand within India who are the top players. So within India, Sachin first, Saurav Ganguly second. So this is how within group by object we can do some operations. So with that, I just wrap it. What we learned after using dplyr package, we learned how to do filtering, we learned how to do group by, we learned how to do summarization and arrange all those. I have given assessment for this week. I've used 2 data sets. Very quickly, I will show you what is that data set, and so that it will be easy for you while working it out. So one is Parliament data set, some of visuals that we were looking on the first day, right? Let me introduce what is this data set is all about. So here, this Parliament data set has information about all the Parliament elections right from 1951 to 2009. So let's take 1 year. So I'm going to filter 1 year, which is, let's say, 2009. For all the states, we have the details. Let me pick one state, Karnataka. And within Karnataka, what is the constituency name? Let's say I want to pick Bangalore. Let's take Bangalore Central. And so for the year 2009, for the state Karnataka, for the PC Bangalore Central, totally 37 candidates contested, and their winning position is also there in the last column called position. Their individual names are available, the individual gender, party to which they belong to, age, category, how much votes they have secured, and what is the total number of people who are eligible for electing or casting their votes is also available. So electors column alone, for a year, state and PC, it will repeat, because ideally in a PC we cannot have multiple electors, because in a PC people who are eligible is going to be a single number, just that we can't have missing values. So data is structured something like it just repeated. So do not do some operations on electors directly. So this is the data set for Parliament, and there is one more data set that I have uploaded, which is IBM Watson HR Analytics data set. So this contains information about different employees, and we have a column called attrition. It says whether the employee is still in the organization or left the organization. 1 means they have left the organization, 0 means they are still in the organization, and different characteristics about the candidates, the employees, their age, the travel department they belong to, and which job role, what is the gender, marital status, likewise multiple other things. Their monthly income is also there. So multiple columns exist. So few of the columns I've used for the assessment. So these 2 data sets are used. So if you have any doubts and all, you can through Divya you can reach out to me, and you will get the questions as well through Divya. So I'll just read out one question. If you have data in XML in a database table, will it possible to use R? Yes, you can use it. And does even if we ignored NA, it shows with 1926 more rows. Yeah, because NA we are ignoring, and we are, let's say there are a player name whose value is missing in 1 row, but for the same player the other rows will have runs. So after grouping by, it is just for every player 1 row. So the player will not be ignored, only that particular match record will be ignored. So finally you will have only 1926 rows. So here when you take the ODI data set, With group by, we have to use summarize like aggregate function. If you do not want to group by, you can also directly go and summarize. For example, if you want to calculate total runs for all the players, that is also something that you can do. So it's not necessary that summarize has to follow group by, followed by group by. So here, for the question that is asked on the missing values, let's say I select the missing rows. We'll pick one player. Let's take mark ewalk as a missing value, but mark ewalk might have other values, so it will not ignore mark completely. Instead, that particular match in which the player run is not available, it will ignore for the calculation at least. So the runs from his other matches will be taken care. So there are totally 1926 players in this particular column. So that's why we get 1926 rows after grouping. So you can also check this in Excel. You go insert, you do a pivot table, new worksheet. So you create player and you create total runs. So you can see start from fourth row. So you can see 1000, close to 1936 rows are available. So that is how R is also going to give you. So it will not go. It will ignore that row, but it will not ignore the player with the other rows. So that's why you have 1936 rows. And the last question, can you use summarize without group by? Yes, as I said, you can use it. For example, very quickly I'll show you. You can say ODI summarize, and you can say I want to directly get for Sachin. So you can say Sachin equal to sum of runs, and you can say player equal to Sachin R Tendulkar. So this is also some group filtering while group by summarizing, and you can also say I want to do it for Shevag. So you can say sum of so you can say sum of runs and player equal to Virendra Sehwag. So in which case one column for Sachin, one column for Sehwag will come separately. So it's not necessary that summarize should come after group by. So there is no null in R. How do we check a vector or data frame is empty or null? You have a function called is.na. So you can say is.na and you can pass ODI, and which will give true or false for all the rows. You can just do a sum. Sorry, you can just do one column. Let's take runs column, and you can say dot sum. So you are checking whether there are NA values in runs column, and for every row it will say true, false, true, false. True if it has missing value, false if it has some value. So when you do sum, you're ideally adding up all those true. So you will have true only if a particular value is missing. So when you do dot sum on a Boolean vector, it will just add up all the trues alone. Sorry, sum of. So it says there are 26 rows which are missing in runs column. So if you want to do it for all columns, you can use call sums is dot na ODI dollar run ODI. So it will do for every column number of rows missing. It will give us simple preview. So single sum, if you are using it on a single column, call sums means column wise sums, and checking is it having NA. So no missing values in country player, but 26 missing values in runs and score rate. So this is how you figure out the number of rows. If you quickly want to identify percentage of missing rows, you can just say n row of ODI into 100. So for every column, it will show you percentage of missing values. So that is something you can try out. And yeah, I guess there is no other doubts. Yeah, so this is what I was planning to cover. We will get it through the assessments. So I would strongly encourage you to look at the assessment very carefully. You can try out one by one. Yeah, I wind up here. Yeah, it will be posted. Divya will be helping into that, and it will be a ungraded assessment because since it's a prerequisite, we do not want to keep it as part of the course. It will be ungraded assessment, but I would strongly encourage you to look at it. Yeah, will you be sharing the file? Yes, I'll be sharing the file. I'll be adding it to my GitHub data where GitHub profile where you have downloaded the reference links also, right? So the same location, I will add this file also in some time.
So if there are no other questions, shall we call it? Shall we end the webinar? Yeah.
Yeah, I think there's only one question. Sorry, Divya. Where all to use square bracket. If you're accessing, if you're doing subscripting, you have to use square bracket. If you're filtering, like where whenever you're accessing a particular column without deep layer, so we were using square brackets. And whenever you are subscripting element in a vector, you have to use square brackets. So in summarize also we used, that's what I'm saying. So we are filtering out specifically here and without a filter command. So that is where we were using the square bracket. So within filter command, you will not use it. Whereas within summarize, if you're not using filter, we'll be using square bracket. So just to differentiate, usually parenthesis we'll be using when we are calling a function. Otherwise, it is just square brackets here. So keep that in mind. Parenthesis is for functions mostly. Any other command syntax that we need to look up other than ones covered here? Maybe as of now, no, because even in videos, for every line that I'm typing it out, I would have given explanation. So even if I'm introducing any new function or new library, I would have given relevant explanation. If not, if you feel something is missing, you can always reach out. Thank you. Thanks everyone.